Okay, so I'm going to give an overview of the situation with the Goldstone solar system radar, and also talk about possibilities of observing near-Earth asteroids with other existing systems. So, 1 year ago, when I spoke at the January SBAG meeting, the Goldstone solar system radar was offline, um, and I'm very glad to report that it is now back online. And we'll say a little bit more about that in a moment, but. Um, Briefly, let's take a quick look at the facilities within the Deep Space Network that have been used to observe asteroids with radar. The principal one, and I hope you can see my cursor here, is the 70-meter DSS-14 antenna at the Goldstone Deep Space Communication Complex, which is about a 3-hour drive north of Los Angeles. It's observed more than 300 near-Earth asteroids dating back into the 1970s. We also, from time to time, use a 34-meter DSS-13 antenna, which is also at the Goldstone site, and receive the echoes with Green Bank and previously with Arecibo. In the last several years, there have been a number of observations, around 10 so far, with antennas transmitting in Australia and then receiving with the Australian Telescope Compact Array or at the 64-meter Parkes facility. 3 other antennas at Goldstone have also been used for phased array tests on a couple of occasions, but are not used on a regular basis. So the Goldstone solar system radar is located on the 70-meter Goldstone antenna. This facility was offline for about 18 months, beginning about 2 years ago, when the second of its 2 klystrons that had been used failed. As has been mentioned in some previous talks, klystrons are microwave amplifier tubes. They're about 2 meters tall. And unfortunately, they do not typically last more than a few years. They're very expensive and difficult to maintain. Prior to the failure of the second klystron, Goldstone had been operating on only 1 klystron for more than a year. So the facility was operating at less than 1/2 power for quite a while. Well, I'm very glad to report that we're now back online at full power. The 1 klystron was delivered in June, a second one was delivered in the fall, and so full power has now resumed as of basically November, so a couple of months ago. So we're back up to a regular power of 450 kilowatts, which is our full sensitivity. In addition, a new spare klystron has been ordered and is being manufactured. So when things are going well at Goldstone, we observe in the realm of 30 to 40 near-Earth asteroids annually. Since resumption of operations in October, 13 near-Earth asteroids have been observed, and also 2020 SO, which is probably the old Surveyor rocket booster from the 1960s. I don't have a lot of time, but I do briefly want to mention that we are planning to observe Apophis coming up in March, and that will be the last radar opportunity for that object until 2029. So a little bit more about Goldstone. In principle, more than 100 near-Earth asteroids could be observed annually if time and resources were not a problem, but it's just not realistic to schedule that many objects. I mean, the antenna is primarily used as a deep space communication facility. Its primary mission is not astronomy. We're very fortunate to be able to piggyback on it as much as we do. Goldstone also operates as a bistatic system, as Karen O'Neill just mentioned, with reception at Green Bank and also with reception at the DSS-13 antenna at the Goldstone site. So the antenna is more than 50 years old. It is becoming more difficult and expensive to maintain it. There are components of their transmitter system that are more than 40 years old that really need to be replaced. In addition to the klystrons, there's a new solid-state transmitter system that's currently under development at JPL. It's a modular system, and if progress continues, it could be a very big help to us, because if a single component fails, it doesn't bring down the whole system. We've also been teaming up, collaborating with colleagues at in Australia to use the 70-meter and 2 of the 34-meter antennas there as radar facilities. The primary one is DSS-43, which is the 70-meter antenna here. That facility is particularly useful because it recently was upgraded by a factor of 4 in terms of its transmitter power with the installation of a new 80 kilowatt klystron. So the Canberra facility, however, none of the antennas are equipped to receive their own radar echoes. So you need to receive with a different facility, which has primarily been with the Australian Array and also with Parkes. So the Australian Array is a few hundred kilometers north of Canberra. It basically is effectively equivalent to one 49-meter antenna. It is often available and has been the facility of choice for receiving. Parkes has also been used, but it unfortunately lacks dedicated receiving equipment for the X-band transmitter frequencies that the Canberra facilities can use. In principle, though, Parkes could more than triple the signal to noise relative to the Array with the acquisition of a dedicated receiver for a few hundred K. So I want to say a little bit about some recent radar results. Since October, there have been, as I mentioned, 13 near-Earth asteroids observed with Goldstone. Some of them have been strong enough to obtain delayed Doppler images. Here are two of those, two objects that are both close to 2 kilometers in diameter. Over the Thanksgiving holiday season, we observed 2000 WO107, which is an object around 600 meters long, shaped like a large bowling pin. This object also has a very high circular polarization ratio, which Dylan Hickson described yesterday. In late December, we observed SD224, a smaller object about 150 meters across that's very angular and rotates once every several hours. We also observed Ryugu. Ryugu would have been a phenomenal imaging target at Arecibo, and we were eagerly looking forward to those observations to help with calibrating the ground truth. We did, however, observe it with Goldstone. We did not get detailed images. The signal-to-noise ratios weren't strong enough, but we do have extensive CW observations. Here are two detections from Canberra that were obtained this month. There's also been a third one that is not shown here. So they've been very busy there, very productive as they're testing out this new 80 kilowatt Klystron. So given the loss of Arecibo, sort of changing directions a bit here, what could be done to replace it? How could we observe more near-Earth asteroids? Well, right now, there aren't any facilities available anywhere in the world that can really come close to replacing Arecibo. I mean, it was more than 10 times more sensitive than Goldstone, and it could see twice the distance. And so Goldstone simply can't do as much as Arecibo could. But there are other facilities that could do more, that could certainly contribute, primarily with very small near-Earth objects. For example, the Haystack facility in Massachusetts could observe potentially dozens of near-Earth asteroids annually. The ISCAT 32-meter antenna in Norway has observed one asteroid and could observe at least a handful each year. The 70-meter facility in Madrid, NASA's Deep Space Network antenna there, could be employed if there were people who were really interested and motivated to do it. And reception would have to occur somewhere else, perhaps in Italy. The TIR facility in Germany could be used. And the upcoming ISCAT 3D phased array radar under construction in Norway holds quite a bit of promise for obtaining radar astrometry, primarily for very close objects, and that could come online within roughly 1 year. There are other facilities that could contribute, but their sensitivities are quite a bit less, and so I don't list them here.
Two more minutes.
Right. Looking into the future, in the next several years, in addition to ISCAT, the possibility of equipping Green Bank with a high-powered transmit is certainly very intriguing. As Karen mentioned, if this rivals the sensitivity of Arecibo for roughly a few tens of millions of dollars, that would be very attractive. In the longer term, some sort of phased array, I think, is probably the way to go. A phased array such as the new Arecibo that Anne described, or potentially some other type of facility that Lindley alluded to yesterday, is really, I think, in the long term, they're really what we need. Those are my own personal opinions. But anyway, so I wanted to just kind of give you a quick overview of where we are, what potentially could be done. And with that, I'll stop. And if we still have time, I'd be glad to take some questions. Thank you.